may or may not have heard of chord. Okay, chord has an H in it, so it's not C-O-R-D, it's C-H-O-R-D. It's a line segment that goes to the endpoints of a circle. So chord can go anywhere as long as 2 endpoints on a circle. So if I have, for example, if I take this point here and I put a dot there, that's also a chord. That's a chord. I can have chords anywhere as long as it's connecting 2 endpoints on the circle. Okay. Central angle means the angle is created from the center of the circle. So you have your dot that represents the center. You have an angle right there. It's created by 2 radii. Again, radii is plural for radius. Inscribed angle. We're talking about that quite a bit today. An angle formed by 2 chords. So this means it can go across the circle. It has to be centralized. So you have two chords that connect to the same point. This forms an angle which we call inscribed. Any questions on those 3 definitions? Chord, central angle, inscribed angle. Okay. Arc, a part of a circumference of a circle. So, for example, AB is an arc. It's part of the circumference. Okay, CD is an arc. It's part of the circumference. Just think about it. It's a piece of the circle which you can consider as an arc of it. Okay. All right, so got some more definitions coming here.
Well, we have to memorize.
Luke, stop being sarcastic. That is on video, so you can listen to that later.
Well, we have to memorize.
You have to know these definitions, yes. Okay? So, inscribed angles. If 2 inscribed angles share the same arc, they are congruent. That is definition number 1 that you're going to want to use. So what that means is that, I'll draw them with colors here. So I have RAS, and I have RBS. These angles are congruent because they go to the same endpoints. So this is what I'm saying. Visualize. This is going to these 2 endpoints. The blue is going to these 2 endpoints. Therefore, those angles are congruent. That's the definition. Okay, I'll draw another quick example just off the top of my head here. So if I take this, let's go here, here. So these 2 angles are congruent. They share the same 2 endpoints. And the weird one is I could do this even. Put a point here, a point here. This still works. These angles are still congruent. Okay, by definition. Is there questions about that? 2 inscribed angles that share the same endpoints are congruent. That's what I'm showing you. Okay. Next one. The measure of a central angle is twice the measure of an inscribed angle that shares the same endpoints. So what that means is this is a central angle of 80. See their endpoints, A and B. Share, share. They go to the same endpoints. This is half, 40. That's the next second thing you need to know. So an inscribed is half of a central with the same endpoints. An inscribed angle is half of the central angle with the same endpoints. Another just example off the top of the head to help maybe. So if I did this, I said, there's my central angle. This is 90. Okay? And I took an inscribed angle. Like that. What would that angle be? 45. That's it, 45. Remember, it's not the position, it's the endpoints. They share these is what's important. That's what's important. It doesn't matter where this point is. I could do this anywhere. I could do it here. That's still going to be 45. Doesn't matter where I'm at. Just as long as the endpoints, it's going to hold that definition. Okay, that's why circles are special. I mean, they have these like things that happen every time. Okay? Any questions? Okay, so I'm going to do a quick refresh here because we've done a lot of quick definitions here. So, chord, 2 points on a circle connected. Central angle, angle that's from the center. I know that's kind of redundant. Inscribed angle, okay, 2 chords connected at a single point, essentially not from the center making an angle. Arc, parts of the circumference. 2 inscribed angles that have the same arc or the same endpoints are equivalent. Central angles are twice as big as inscribed angles to the same arc or same endpoints. Okay, questions? We're good? Okay. All right. Example 1. Let's look at this. Let's see if we can figure these out. Okay, point C is the center of the circle. AEB is 35. What's the measure of ADB? 35. Okay, if you said 70, it's not center. Yeah, so this guy here. Right? So that's 35 as well. Same arc. They both finish here. The measure of ACB is your 70. Twice the inscribed. You're confused? Okay, what's the confusion? This one? Okay, so the definition states that the central angle is twice as big as the inscribed angle that it shares the same endpoints with. So if this is 35, 2 35s is 70, so that makes it 70. Does that make sense? That's the definition in terms of inscribed and center. Okay. Can we continue? All right. Okay, so these ones, a little show your nose. Let's see here. We'll go ahead and start over at Olivia. We'll kind of go around the room for these. So Olivia, what's the measure of DEB? Okay, who wants to help her?
What one?
DEB. You want to help, Jack? Oh, that's all right. I think Luke's ready. We'll come back to you. Luke?
Isn't it the exact same angle?
It's the exact same angle. Okay, look. Is this central? It's not central, right? This angle and this angle are the same. They have the same endpoints, so it's 55. You put same arc for an inscribed angle. Liv, does that make sense? They have the same arc, so they go to the same spot. So let me show you one more time here. Let's do the highlighter here. So the one they asked me, these angles are equivalent because they both go to DB. All right, so DEB is inscribed. Whoops, should have stole that one from Emily. So I said this, Emily, they share the same what? Arc. They have the same angle because they share the same arc, okay? Yeah, DAB and DEB are both what, Abby? So the DAB and they're both 55, yep. Okay, good. Bree, what is the measure of DCB? Nope, double. The central is twice as big as 110. Okay? So remember, it's DCB is 55 times 2. Times 2 again, which is 110. Okay, you guys see what I'm talking about? It's very definition based. Like if you don't know central angle is twice as big, you miss it. I know everyone here can times by 2, but if you don't know that's what you're supposed to do, then you're going to miss it. All right. So point C is the center of the circle, diameter of 10. BD is 6. What is the measure of ADB? Justify your answer. Aiden, you want to take a shot at this?
ADB?
Yeah, what do you think that angle measure is? I haven't taught you this, so you shouldn't know. I'm asking for you to make an educated guess.
You could probably work Pythagorean Theorem there, couldn't you?
Do we know it's a 90? We're asking for the angle right now.
No, but it was pretty close.
Pretty close. Okay. Okay, so you're saying some really good things. Okay, this is what makes it 90 by definition. This right here, this is not a central angle, correct?
Yeah.
Correct, thank you. It's inscribed. But it's inscribed on top of the what? Which makes this 90 because it's half of the 180. So what you're saying is exactly right. So what I'm saying is, listen, this diameter, what's the degree measure of a diameter? 180. That's the inscribed of 180. So what's the definition for inscribed? You take half of it. So all you need to know, okay, all you need to know is that if you have two chords that go to the end of the diameter, that's 90 every time. So let me show you what I'm talking about. If I take this, I do a diameter. I'm going to take this point here. If I go here and I go here, that's 90 every time. See that? Diameter, that's 90. By definition, this is why. Technically, this right here is a central angle of 180. This is an inscribed angle, so half of 180 is 90. That's by definition what's happening. Okay, questions on that? What's wrong, Parky? I just should understand. Do you understand it?
Before I understand what he's saying.
Oh, okay, good. I thought you said you didn't. I was going to say, if you didn't, then tell me why. Okay, any other questions? So does that make sense? So essentially, your definition for there, two chords that go to the outside ends of your diameter form a 90-degree angle. Okay, so this right here is 90 degrees. We've already justified this out loud a bunch. Because it's half of 180, and 180 is a straight line. What's the length of AD? Now we can use Pythagorean Theorem to figure that out. Okay, it'll end up being 10 squared minus 6 squared, which is 64. Square root of 64, you're going to get 8. I just did Pythagorean Theorem backwards there. Okay, because we're trying to get that side. 10 squared is 100. 6 squared is 36. 100 minus 36 is 64. We square root it for 8. 8 is that opposite side here. Yes, ma'am. B, yep. Okay, so Pythagorean Theorem is this right here, right? So this right here is my C. So it's going to be 6 squared plus B squared equals 10 squared. We're going to minus that 6 squared over because we're trying to solve for B now. Like that. And so that's where I got that from. So I just picked up from here. Okay. Anything else? Okay. All right. So let's look at this guy. Point C is the center of the circle. ACB. AB is the diameter. Okay. So Stewie, what is the measure of ACB? Right, it's a straight line, good. And then 180. Inscribed central. So what is ADB, Blackie? Yeah. The right here. Right, that's what we just learned, right? So it's 180 divided by 2, so 90. All right. Okay, Woodsky, what would I do? What would I put here to solve for AB? Yeah, like what would go in these boxes here? Yeah. 12 squared plus 5 squared. 144 plus 25. 169. So we're going to get 13. So diameter is 13. Okay, 13 and 13 there, those last two boxes. All right, last couple here. This one already has a solution on it. Okay. Jamie photographed his house using a lens with a 7-degree field view. He wants to take another photo, but only wants a lens with 35-degree field view. Where could he stand to take the photo of the whole house? Okay, so he's at 70 right now, and that's his view. This essentially is our central angle. So we would draw our circle. So what's going to happen is, if he just steps back over here, as inscribed, he's going to get 35. Okay, so he can take that from anywhere that he wants as long as he has the endpoints of the house on the other side of the circle.
So you have to go anywhere around the circle.
Right, and that's what the solution's showing you. So any of these dots would work. Here, 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 anywhere, okay, on the outside of the circle. Which, what you need to figure out is how far is he from the house, okay, and then that distance is how far is going to be around. That's why on this one, guys, it says where could he stand? That means there's options. It's not like a specific spot. Where could he stand? You would just put essentially anywhere on the outside of the circle where he can get view of the two endpoints of the house. Okay, let's look at this last one here, and we're done. Okay, camera has a field view of 50 degrees. A flashlight has a field view of 25 degrees. Where could you put the flashlight so it'll cover the same field? Camera. So just what you're going to put right there. You can put it one spot. You can pick any spot you want. That right there would get you 25. They're just selling you on divide by 2.
What would be one reason to choose this? Just because it was
Just simply, they want you to say, because it inscribes half of central.
inscribed.
Half of central, yeah. Okay.